This example is like problem 15 and 16 in the exam 3 review. We are doing a complete hypothesis test. Research question here is, are we getting fatter? So according to the CDC, the mean weight of U.S. men was 190 pounds in 2000. That's our base time. Took a sample of 50 men in 2020, 10 years later. The mean of that sample was 194. Public health officials want to determine whether the mean weight, mu, for the population has increased since 2000. So we're going to assume population standard deviation of sigma is 12, test at alpha is 0.01, and we're using the p-value method. So let's write down some of our values here. We're going to test against the 190. That's going to be our hypothesized mean, because we're testing to see if it's increased from 190. The 50 is our sample size, so n is equal 50. And let's see, population standard deviation is 12. And x bar was 194. So we want to test and see if it's increased. So our alternative hypothesis would be that the mean is greater than 190. And if that's not the case, then we conclude that the mean is still 190, what it was in 2000. So first, compute the value of our test statistic. So we're given sigma, so we're going to use the z distribution. So our test statistic is a z value, not a t value. X bar minus the hypothesized mean, so x bar is 194, minus the hypothesized mean of 190. We are dividing by sigma is 12 over square root of 50 is our n. So let's compute that real quick. So alpha y equal nr to get a horizontal fraction. 194 minus 190 in the numerator. Denominator 12 divided by square root 50 gives us 2.36. And they said round to at least two decimal places, so we rounded to 2. Next, we're finding the p-value to 4 decimal places. So actually, when you find your p-value, probably should use at least 3 decimal places in your test statistic. So 357. So 357, which is approximately 2.36. And the p-value is the area past the test statistic. So here's our sampling distribution. So that's the x bar distribution. It has a mean of 0. And our test statistic is 2.36, so that'll be out here to the right. And we want to find the area past that 2.36. That is our p-value. So we're going to use normal CDF to do that. Our left-hand cutoff is 2.36. Our right-hand cutoff, infinity, we'll use 10,000. And then mean and standard deviation, we're going to use 0 and 1 because we're dealing with z-scores. So we'll go to second variables, normal CDF. 2.36 is our lower, upper 10,000. Mean we need 0, standard deviation 1, paste 0.0091. And then you can also use stat test z-test to get those test statistics. Let's demonstrate that. So stat test, z-test is that first one. Let's see, our hypothesized mean is 190. Our standard deviation 12. X bar 194. Sample size n is 50, and this is a greater than test, so highlight the greater than. And if you go ahead and hit calculate or draw, draw will draw the distribution for you so you can see it's right-tailed. Z 2.357, and that's what we had here. And P 0.0092, and we had 0091. So, and that's because we rounded to 3 decimal places here. If you did not round, if you kept full accuracy, you get the 0092. Now, just a note, if you only keep 2 places in that z-score, we do, let's see here, second variables, normal CDF is 2, and if we did that was 2.36, we got 0091. So if we use 2.357, if we use 3 decimal places of accuracy there, and still the 10,000, and still the 0 and the 1. So the only difference is I used 1 more decimal place in my lower limit. Then, let's see, did I do that right? 357. Oh, I hit a divided sign. Let's do this again. Second variables, normal CDF, enter. So 2.357. There we go. Everything else stays the same. And there's the 0092. So if you round off your z-value, your p-value might be off in the last decimal place. So we would actually like to use the 357 here. And then this will be 0092, which will have all the accuracy of the calculator if it does the calculation itself. So maybe don't round that z-value when you're finding the p-value. And then now we want to determine whether we're going to reject the null hypothesis. Well, our p-value is 0.0092. We are testing that against alpha is 0.01 here. And 0092 is less than 0.01, which is our alpha. So that means that we are going to reject H0. This is a significant result. So our conclusion is that there is enough evidence to conclude that the mean weight in 2020 for men is greater than the mean in 2000.